A mortar is a weapon that fires explosive projectiles known as bombs at low velocities, short ranges, and high arcing ballistic trajectories. It is typically muzzle-loading with a short, often smoothbore, barrel, generally less than 15 times its caliber. Mortar bombs are often referred to, incorrectly, as mortars. History. Origins. Mortars have been used for hundreds of years, originally in siege warfare. Many historians consider the first mortars to have been used at the 1453 siege of Constantinople by Fatih Sultan Mehmed. A European account of the 1456 siege of Belgrade by Giovanni da Tagliacozzo said that the Ottoman Turks used 7 mortars that fired stone shots, 1 Italian mile high. The time of flight of these was apparently long enough that casualties could be avoided by posting observers to give warning of their trajectories. Early mortars, such as the Pumhart von Stier, were also large and heavy, and could not be easily transported. Simply made, these weapons were no more than iron bowls reminiscent of the kitchen and apothecary mortars from where they drew their name. An early transportable mortar was invented by Baron Menno van Coehoorn. These mortars fired an exploding shell, which had a fuse lit by the hot gases when fired. This innovation was quickly taken up, necessitating a new form of naval ship, the bomb vessel. Mortars played a significant role in the Venetian conquest of Morea, and in the course of this campaign an ammunition store in the Parthenon was blown up. An early use of these more mobile mortars as field weapons was by British forces in the suppression of the 1719 Jacobite rising at the Battle of Glen Shiel. High-angle trajectory mortars held a great advantage over standard field guns in the rough terrain of the West Highlands of Scotland. Coehorn-type mortars of approximately 180 pounds weight were used by both sides during the American Civil War. At the Siege of Vicksburg, General U.S. Grant reported making such mortars by taking logs of the toughest wood that could be found, boring them out for 6 or 12-pound shells and binding them with strong iron bands. These answered as coehorns, and shells were successfully thrown from them into the trenches of the enemy. The mortar had fallen out of general use by the Napoleonic era. Interest in the weapon was only revived at the beginning of the 20th century. During the Russo-Japanese War, Lieutenant General Leonid Gobiato of the Imperial Russian Army applied the principles of indirect fire from closed firing positions in the field, and, with the collaboration of General Roman Kondratenko, he designed the first mortar that fired Navy shells. The solution they developed was a short-barreled rifled muzzle-loading mortar called the Minenwerfer, and was built in 3 sizes. Recognizing the advantages of the Minenwerfer in trench warfare, production was stepped up and, by 1918, the numbers had increased dramatically to 1,234 heavy, 2,361 medium and 12,329 light Minenwerfer. The Approved was a mortar used to test the strength of gunpowder. It fell out of use by the middle of the 19th century. Modern portable mortar. It was not until the Stokes trench mortar devised by Sir Wilfrid Stokes in 1915 during the First World War, that the modern mortar transportable by one person was born. In the conditions of trench warfare, there was a great need for a versatile and easily portable weapon that could be manned by troops under cover in the trenches. Stokes's design was initially rejected in June 1915 because it was unable to use existing stocks of British mortar ammunition, and it took the intervention of David Lloyd George and Lieutenant Colonel J.C. Matheson of the Trench Warfare Supply Department to expedite manufacture of the Stokes mortar. The weapon proved to be extremely useful in the muddy trenches of the Western Front, as a mortar round could be aimed to fall directly into trenches, where artillery shells, due to their low angle of flight, could not possibly go. The Stokes mortar was a simple weapon, consisting of a smoothbore metal tube fixed to a base plate with a lightweight bipod mount. When a mortar bomb was dropped into the tube, an impact-sensitive primer in the base of the bomb would make contact with a firing pin at the base of the tube, and detonate. firing the bomb towards the target. It could fire as many as 25 bombs per minute and had a maximum range of 800 yards, firing the original cylindrical unstabilized projectile. A modified version of the Mortar, which fired a modern fin-stabilized streamlined projectile and had a booster charge for longer range, was developed after World War I. This was in effect a new weapon. By World War II, it could fire as many as 30 bombs per minute, and had a range of over 2,500 yards with some shell types. The French developed an improved version of the Stokes mortar as the Brandt MLE-27, further refined as the Brandt MLE-31. This design was widely copied with and without license. About 700 Stokes mortars were acquired by Poland between 1923 and 1926. These weapons were the prototypes for all subsequent light mortar developments around the world. Mortars today, while substantially similar in design to the Stokes mortar, are greatly improved versions. These offer a weapon that is light, adaptable, easy to operate, and yet possesses enough accuracy and firepower to provide the infantry with quality close fire support against soft and hard targets more quickly than any other means. Largest mortars. The largest mortars ever developed were the Belgian Monster mortar, Malay's mortar and the Little David. All three mortars had a caliber of 36 inches, but only the Monster mortar saw action. The largest mortars to see active use in modern warfare were the German 60 cm Kulgerat. Improvised mortars. Improvised, or homemade, mortars have been used by insurgent groups, usually to attack fortified military installations or to terrorize civilians. The Provisional Irish Republican Army used some of the best-known examples during the 1970s, 1980s and 1990s. The largest types came to be known as barracks busters, and were usually constructed from heavy steel piping mounted on a steel frame. The largest had a caliber of 320 mm and fired homemade rounds carrying from 80 to 100 kilograms of explosive. As each tube fired only one round, mortars were usually deployed as a battery of 4 or 6 welded onto a steel frame. This was often concealed inside a van, such as a Ford Transit. The vehicle would be parked, pointing roughly at the target. A timer fired the propellant charges after a delay. This allowed a mortar gunner time to escape. After firing, a timer-operated incendiary device could set the vehicle on fire in order to destroy any forensic evidence it contained. Well-known incidents using these weapons include the 1985 Newry mortar attack, when 9 members of the Royal Ulster Constabulary were killed, and the Downing Street mortar attack in 1991. In the latter, the IRA launched 3 bombs at 10 Downing Street, the British Prime Minister's residence, during a cabinet meeting there. The only bomb that detonated landed in the building's back garden, and shattered the rear windows. Prime Minister John Major had to move to Admiralty House while repairs were effected. Function. The mortar is a relatively simple and easy weapon to operate. A modern mortar consists of a tube into which assistant gunners drop a purpose-designed bomb. The tube is generally set at an angle of between 45 and 85 degrees to the ground, with the higher angle giving shorter firing distances. The bomb has a small baseline charge and no cartridge case. For extra range, propellant rings are attached to the bomb's fins. When it reaches the base of the tube, the bomb hits a fixed firing pin, which detonates the baseline charge and fires the projectile. Some mortars have a moving firing pin, operated by a lanyard. Others may be fired by a trigger. These attributes contrast with the mortar's larger siblings, howitzers and field guns, that fire shells at higher velocities, longer ranges, flatter arcs, sometimes using direct fire. These weapons are also breech-loaded, while most mortars are muzzle-loaded. From the 17th to the early 20th century, very heavy, relatively immobile siege mortars were used, of up to 1 meter caliber, often made of cast iron and with an outside barrel diameter many times that of the bore diameter. An early example was Roaring Meg, used during the English Civil War. Smaller and more portable designs were introduced during the First World War, primarily for trench warfare, which took place at relatively close ranges. Mortars continue to be used by militaries to the present day. Light and medium mortars are portable, and usually used by infantry units. The chief advantage a mortar section has over an artillery battery is the flexibility of small numbers, mobility and the ability to engage targets in cover with plunging fire. Mortars are able to fire from the protection of a trench or other type of cover. In these aspects, the mortar is an excellent infantry weapon, as it can be transported over any terrain and is not burdened by the logistical support needed for artillery. Heavy mortars are typically between 120 and 300 mm caliber. These weapons are usually towed or vehicle-mounted, sometimes breech-loaded, and normally employed by infantry units attached to battalion through division level. Even at this size, mortars are simpler to operate and less expensive than comparable howitzers or field guns. A mortar can be carried by one or more people, or transported in a vehicle. Heavy mortars can be mounted on a towed carriage, or permanently vehicle-mounted as a self-propelled mortar. Twin-barreled self-loading mortars, such as the Patria Amos PT-1, are the latest evolution of these heavy mortars and are mounted on platforms such as armored personnel carriers, tank chassis, and coastal patrol boats. A mortar can also be a launcher for fireworks, a handheld or vehicle-mounted projector for smoke shells or flares, or a large grenade launcher. Design. Most modern mortar systems consist of three main components: a barrel, a base plate, and a bipod. Modern mortars normally range in caliber from 60 mm to 120 mm. However, mortars both larger and smaller than these specifications have been produced. An example of the smaller scale is the British 51 mm light mortar, which is carried by an individual and consists of only a tube and a base plate. Conversely, a large example is the Soviet 2S4M1975 Tyelpin 240 mm self-propelled mortar. Smaller mortars are commonly used and transported by infantry-based mortar sections as a substitute for, or in addition to, artillery. Ammunition for mortars generally comes in two main varieties: fin-stabilized and spin-stabilized. Examples of the former have short fins on their posterior portion, which control the path of the bomb in flight. Spin-stabilized mortar bombs rotate as they travel along and leave the mortar tube, which stabilizes them in much the same way as a rifle bullet. Both types of rounds can be either illumination, smoke, or high explosive. There are also training rounds and precision-guided rounds, such as the Strix mortar round. Operators may fire spin-stabilized rounds from either a smoothbore or a rifled barrel. Rifled mortars are more accurate, but slower to load. Since mortars are generally muzzle-loaded, mortar bombs for rifled barrels usually have a pre-engraved band, called an obturator, that engages with the rifling of the barrel. Exceptions to this were the U.S. M2 4.2-inch mortar and M30 mortar, whose ammunition had a sub-caliber expandable ring that enlarged when fired. This allows the projectile to slide down the barrel freely, but grip the rifling when fired. The system resembles the mini A-ball for muzzle-loading rifles. Mortars are made in a range of calibers. The French 81 mm mortar became standard for many countries, while the Soviet bloc standardized on the 82 mm mortar. Mortars suffer from instability when used on snow or soft ground, because the recoil pushes them into the ground or snow unevenly. A ration bag addresses this problem. Distinctive features of mortars: modern mortars and their ammunition are generally much smaller and lighter than artillery. such as guns and howitzers, which allows light and medium mortars to be considered light weapons, i.e., capable of transport by personnel without vehicle assistance. They are short-range weapons, and often more effective than artillery for many purposes within their shorter range. In particular, due its high, parabolic trajectory with a near-vertical descent, the mortar can land bombs on nearby targets, including those behind obstacles or in fortifications, such as light vehicles behind hills or structures, or infantry in trenches or spider holes. This also makes it possible to launch attacks from positions lower than the target of the attack. Higher, a target easily accessible to a mortar. Mortars are also highly effective when used from concealed positions, such as the natural escarpments on hillsides or from woods, especially if forward observers are being employed in strategic positions to direct fire, an arrangement where the mortar is in relatively close proximity both to its foe and its target, allowing for fire to be quickly and accurately delivered to lethal effect. Fin-stabilized mortar bombs do not have to withstand the rotational forces placed upon him by rifling or greater pressures, and can therefore carry a higher payload in a thinner skin than rifled artillery ammunition. Due to the difference in available volume, a smoothbore mortar of a given diameter will have a greater explosive yield than a similarly sized artillery shell. For example, a 120 mm mortar bomb has about the same explosive capability as a 155 mm artillery shell. Also, fin-stabilized munitions fired from a smoothbore, which do not rely on the spin imparted by a rifled bore for greater accuracy, do not have the drawback of veering in the direction of the spin. Spigot mortars, a particular type of mortar, consist mainly of a solid rod or spigot, onto which a hollow tube in the projectile fits, inverting the normal tube mortar arrangement. At the top of the tube in the projectile, a cavity contains propellant, such as cordite. There is usually a trigger mechanism built into the base of the spigot, with a long firing pin running up the length of the spigot activating a primer inside the projectile and firing the propellant charge. The advantage of a spigot mortar is that the firing unit is smaller and lighter than a conventional tube mortar of equivalent payload and range. It is also somewhat simpler to manufacture. Further, most spigot mortars have no barrel in the conventional sense, which means ammunition of almost any weight and diameter can be fired from the same mortar. The disadvantage is that while most mortar bombs have a streamlined shape towards the back that fits a spigot mortar application well, using that space for the spigot mortar tube takes volume and mass away from the payload of the projectile. If a soldier is carrying only a few projectiles, the projectile weight disadvantage is not significant. However, the weight of a large quantity of the heavier and more complex spigot projectiles offsets the weight saved due to the spigot mortar being lighter than a conventional mortar. A near-silent mortar can operate using the spigot principle. Each round has a close-fitting sliding plug in the tube that fits over the spigot. When the round is fired, the projectile is pushed off the spigot. But before the plug clears the spigot, it is caught by a constriction at the base of the tube. This traps the gases from the propelling charge and hence the sound of the firing. After World War II, the Belgium Flyke silent spigot mortar was accepted into French service as the TN8111. Spigot mortars are generally out of favor in modern usage, replaced by small conventional mortars. Military applications of spigot mortars include the 290 mm petard mortar used on the Churchill AVRE by Britain in World War II. The 320 mm Type 98 mortar used by Japan in World War II to some psychological effect in the battles of Iwo Jima and Okinawa. Anti-tank launchers. The Blacker Bombard and PIAT anti-tank launcher used by Britain in World War II utilized a spigot mortar type of launcher. Anti-submarine launchers. The Hedgehog launcher, used from the deck of a ship, used 24 spigot mortars which fired a diamond pattern of anti-submarine projectiles into the sea ahead of the ship. A sinking projectile detonated if it struck a submarine, and the pattern was such that any submarine partly in the landing zone of the projectiles would be struck one or more times. Non-military applications include the use of small-caliber spigot mortars to launch lightweight, low-velocity foam dummy targets used for training retriever dogs for bird hunting. Extremely simple launchers use a separate small primer cap as the sole propellant. Gun mortars. Gun mortars are hybrid weapons, the archetype being the Brandt 60mm LR gun mortar, which combine features of modern infantry mortars together with those of modern cannon. Such weapons are smoothbore, firing fin-stabilized rounds, using relatively small propellant charges in comparison to projectile weight. They have short barrels in comparison to guns and are much more lightly built than guns of a similar caliber or characteristics of infantry mortars. However, they also have gun-like features, such as vehicle mountings together with sighting systems that allows direct fire, breech loading and recuperation, some such as the 2B9 Vasileka autoloading. This produces a weapon capable of engaging area targets with indirect high-angle fire, and also specific targets such as vehicles and bunkers with direct fire. Such hybrids are a lot heavier and more complicated than infantry mortars, superior to rocket-propelled grenades in the anti-armor and bunker-busting role, but have a reduced range compared to modern gun howitzers and inferior anti-tank capability compared to modern anti-tank guided weapons. However, they do have a niche in, for example, providing a multi-role anti-personnel, anti-armor capability in light mobile formations.